Now on WCNC Charlotte, hurricane season is now underway, and we're helping you get prepared.
A disaster does not have to have a loss of life with preparation and understanding of what's happening.
We're walking you through hurricane predictions for the upcoming season, explaining the science behind hurricanes, and showing you just how powerful they can be. We're also taking a look back at the devastation from Helene and how communities are still working to rebuild.
The old Chimney Rock is gone, but the new Chimney Rock that we're going to rebuild, it's going to be an amazing place.
Hurricane IQ, a WCNC Weather Impact Special, starts right now. Thanks for joining us here on WCNC Charlotte. I'm Chief Meteorologist Brad Panovich. Before we take a look at what's coming up this hurricane season, we want to take a look back at the 2024 Atlantic hurricane season. The Atlantic Basin saw 18 named storms in 2024. 11 of those were hurricanes, and 5 intensified to major hurricanes. Now, 5 hurricanes did make landfall in the U.S. It was a record-setting season, too. Hurricane Beryl was the earliest Atlantic storm that became a Category 5 hurricane on record. It caused significant storm surge flooding across parts of Texas, Louisiana, and made landfall in Texas as a Category 1 hurricane. Now, Hurricane Helene made landfall as a Category 4 storm on the Florida Gulf Coast on September 26th. The next day, it caused catastrophic flooding across western North Carolina. Helene was the deadliest hurricane to affect the continental U.S. since Katrina back in 2005. Now, the majority of those deaths actually happened in North and South Carolina due to flooding. Less than 2 weeks later came Hurricane Milton. It made landfall as a Category 3 storm near Siesta Key, Florida, and resulted in a tornado outbreak that produced 46 tornadoes and caused torrential rain and localized flooding. Milton's rate of rapid intensification was among the highest we have ever observed. Now, let's look at 2025. It's the hurricane forecast for this season that we're concerned about, and the things that we worry about first are the ENSO phase. What is that? Well, is it La Nina, La Nada, or El Nino? Depending on what phase we're in will dictate what type of season we have. Right now, the forecast is somewhere between La Nina and La Nada, which is the name for the neutral phase of that setup. That means temperatures here in the eastern Pacific are near normal or slightly below. You see some of the blue showing up right now. If this trends towards La Nina, we expect above average amount of storms in the Atlantic. But right now, even in a neutral phase, the forecast from all the major agencies, including NC State, Colorado State, and the National Hurricane Center, you can see are all above normal for named storms, hurricanes, as well as major hurricanes. On average, it's 14, 7, and 3. So we expect an above normal hurricane season because of that warm water that's already developed in the Atlantic as well as the Caribbean. Those areas could see early development of storms even in June. Now, for our area, what are the chances that we see a Category 1 storm impact us? Well, there's a 46% chance in North Carolina. There's a 35% chance for South Carolina. Now, the chance of a named storm, which means even a tropical storm, is even higher. 76% chance for North Carolina, 66% chance for South Carolina. What about a major hurricane? Remember, that means Category 3 or higher. Believe it or not, even though South Carolina has a smaller coastline and doesn't stick out as far, there's actually indications there's a higher chance for a major hurricane in parts of South Carolina as opposed to North Carolina. But remember, storms that hit our coast can be impactful here. But as we've seen in the last couple of years, especially considering Helene, major storms that come up through Florida actually have a more significant impact on the western Carolina. So watching storms down in the Gulf are just as important as off the Carolina coast. So what will this year's storms names be? Well, once they form, WCNC Charlotte meteorologist Majestic Storm shows us why the storms are named, the names to watch out for, and why some letters are never used again.
Well, the message is clear. Be prepared. NOAA, the National Oceanic and Atmospheric Administration, is predicting an above-average season with a 60% chance of increased activity in the Atlantic Basin. Here's the list of names for the storms this year. The names come from English, Spanish, and French, the 3 predominant languages spoken throughout the Atlantic Basin. That diversity reflects the wide area these storms can affect, from the U.S., the Caribbean, to Central and South America. Now, you might might notice not every letter of the alphabet is represented, and that's intentional. The letters Q, U, X, and Y, and even Z are all skipped each year because there's simply not enough common names starting with those letters across all three languages. Names alternate between male and female and are reused every 6 years unless retired. If all 21 names are used in one season, a supplemental list is activated, replacing the old practice of using the Greek alphabet. So whether we see Andrea or Wendy, being ready ahead of time is your best defense when preparing for storms.
Thanks, Majestic. There's a lot of terms you'll hear tonight, as well as during the hurricane season. WCNC meteorologist Chris Mulcahy walks us through some of the key tropical terms you're going to want to know.
These are the terms you need to know this hurricane season. Let's jump right into it and raise that weather IQ. Tropical disturbance. This is simply an area of thunderstorms in the tropics that has some organization. But these can turn into an invest. An invest is short for investigation area, meaning a disturbance is being watched by a forecast center and models are tracking it. For example, in the Atlantic, the first investigation area will be Invest 90L, continuing up to 99L before repeating back to 90. When a disturbance is forecast to make landfall as a tropical storm or hurricane within 48 hours and isn't named yet, a PTC or potential tropical cyclone will be issued. The National Hurricane Center started this in 2017, allowing them to issue advisories earlier. Once a rotating disturbance becomes a closed surface low and has one closed isobar like this, and has sustained winds up to 38 miles per hour, we now have a tropical depression. Tropical depressions are numbered, not named. As the circulation becomes faster and tighter, so do the sustained winds. Once those winds are at least 39 miles per hour, a tropical storm is named. Tropical storm winds range from 39 to 73 miles per hour. When winds are 74 miles per hour or greater, a hurricane is born. A hurricane is graded on the Saffir-Simpson scale. Once a hurricane reaches Category 3, it's considered a major hurricane. Note, all the above are tropical cyclones, and once they're at the end of their life cycle, they become post-tropical cyclones, going by one of two names: a remnant low, when winds are less than 39 miles per hour, or an extratropical cyclone, which can still have hurricane-force winds, but is no longer tropical.
So other terms you'll hear a lot are El Nino and La Nina, like I mentioned earlier. So what exactly do those mean? WCNC meteorologist Brittany Van Voorhees walks us through those terms.
The El Nino Southern Oscillation is one of the most important climate phenomena on Earth and has the ability to change atmospheric circulation, temperatures, and precipitation across the globe. Often, this also influences tropical activity. During an El Nino event, the Pacific Ocean is warm and wet. Less vertical wind shear in this region results in more storms. However, the opposite is true for the Atlantic Basin near the Carolinas. El Nino is associated with higher wind shear, which rips storms apart before they can strengthen. This typically means less storms form, or the storms that do form are weaker. The opposite of El Nino is La Nina. This is a cool and dry pattern for the Pacific, allowing for less storms and more wind shear. Again, the opposite is true in the Atlantic. In the Atlantic, we see lower wind shear, which generally means a more active season with stronger and more frequent storms. There's also a neutral pattern referred to as La Nada. Even though this pattern does not enhance or diminish storm activity, some of the deadliest hurricanes have made landfall during this neutral period. Two notable hurricane seasons that occurred during La Nada, 2005 and 1992. Both of these seasons saw devastating United States landfalls with Hurricanes Katrina and Andrew. The cycle of El Nino is just one of many forecast tools in our complicated atmosphere.
Well, I don't need to tell you this, but up to 100 people a day move to Charlotte. And because of that, some of you have never dealt with a hurricane before. And while most think that hurricanes are only on the coast, we still deal with impacts well inland. WCNC meteorologist Becca Birdsall has more on how you can be prepared locally.
As we step into hurricane season, it's important to understand what tropical weather means for us in the Queen City, especially if you're new here. We're far enough inland that we don't typically get the full force of a hurricane like those on the coast do. But that doesn't mean we're safe from serious impacts. We often deal with the remnants of tropical storms and hurricanes. Think heavy rain, strong winds, flash flooding, and even tornadoes. Take Hurricane Hugo in 1989. It made landfall near Charleston as a Category 4, but even by the time it reached Charlotte, it was still a Category 1 hurricane. Winds peaked in Charlotte with a gust of 100 miles per hour. Tropical Storm Fred in 2021 brought 12 confirmed tornadoes between North and South Carolina in one day, all of which were rated EF0 or EF1. And just last year, Hurricane Helene, though not a direct hit, dumped heavy rain and triggered landslides and flash flooding across western North Carolina. So here's what you need to know. Always have a way to receive weather alerts, especially overnight. Make a plan in case of power outages or flooding, and stay weather alert and keep up to date with the forecast during hurricane season. And remember, just because we're not on the coast doesn't mean we're not impacted.
All right, thanks, Becca. North Carolina's top insurance official says now is the time to get ready. Commissioner Mike Casey says, urging everyone to make sure you check your insurance, gather those important documents, and make an inventory of your home. He warns that flood damage isn't covered by most homeowners policies and says there's a 30-day wait for new flood insurance, so you need to get in on it now. You've probably heard of the eye of the hurricane before, but did you know the eye wall can be replaced? Chris Mulcahy walks us through the process coming up after the break. Plus, we walk through why hurricanes move the way they do. Welcome back. A staple of almost every strong hurricane is an eye wall replacement cycle. But what is that, and why can it be so dangerous? Chris Mulcahy walks us through it.
Hurricane Milton was a historic storm and one of the strongest on record. It also showed a textbook example of a phenomenon called the eye wall replacement cycle. Let's raise that weather IQ. A well-defined eye is a sign of a powerful hurricane. The strongest winds and heaviest rains surround this area, which means it can be volatile, forcing it to go through changes. The eye wall replacement cycle is simply the process in which a hurricane develops a new eye. The eye wall is made up of strong thunderstorms. Intense tropical cyclones like Milton can develop an outer ring of thunderstorms that slowly moves inwards. This robs the inner eye wall of its needed moisture and momentum, causing it to collapse and be filled in, as you can see here on the satellite imagery. During this phase, the hurricane is weakening, but only temporarily. This process can range approximately anywhere from 6 to 54 hours to complete, but on average takes a day or so. During Hurricane Milton's eye wall replacement, the monster Category 5 went from its peak of 180 miles per hour to sustained winds of 145. Once the new larger eye wall took control and eroded the clouds, Milton re-intensified back to 160 miles per hour, where tropical cyclones often re-intensify after the eye wall replacement. A new expanded eye can allow a hurricane to grow in diameter, spreading out the storm's wind field, impacting more people. The eye wall replacement cycle doesn't happen for every hurricane, but it is common for major Category 3, 4, and 5 hurricanes.
During hurricane season, one of the most common questions we get asked is, why do storms move the way they do? Brittany Van Voorhees is raising our weather IQ as she explains steering currents.
The strongest hurricanes can pack winds up to 200 miles an hour, but the winds within the storm are not what pushes them across the ocean. That job is reserved for steering currents. Steering currents refer to the winds that influence the direction a storm system will move. Hurricanes and tropical storms would just sit in the open ocean without steering currents to push them east to west. This is different from non-tropical weather systems like fronts and areas of high and low pressure. These generally move from the west to the east. The boundary that separates these winds is called the subtropical ridge of high pressure. It's farther south in the winter and farther north in the summer. South of the high, trade winds blow east to west, whereas north of the ridge, the westerlies blow west to east. This is why we frequently see tropical cyclones eventually curve out to sea once they travel far enough north. Unfortunately for meteorologists, these steering currents change constantly due to varying atmospheric weather patterns. This is one of the reasons why we track every small change in a storm. This can mean a location shift in the eye, the storm slowing down, or rapid intensification. These minor adjustments can cause tropical cyclones to have erratic patterns.
So we've learned more about the eye of the hurricane and why it moves the way it does, but how can it weaken a hurricane? We walk you through that coming up on the other side of the break. Since 1924, there have been 42 Category 5 hurricanes in the Atlantic Basin. While many of these storms have peaked at Category 5, only 4 have made landfall in the United States at that strength. Chris Mulcahy has the history of Category 5 storms for us tonight.
There aren't many things more infamous than a Category 5 hurricane. Cat 5s are catastrophic, terrifying, and even rare. Let's raise that hurricane IQ. Hurricanes are ranked into 5 categories via the Saffir-Simpson scale. For a hurricane to reach Category 5 status, it must have sustained winds of 157 miles per hour or greater. Hurricane record keeping dates back to 1842, but the first Category 5 wasn't documented until 1924. This hurricane made landfall on the extreme western side of Cuba with sustained winds of 165 miles per hour. The first 9 Category 5s from 1924 to 1944 were unnamed, since the hurricanes weren't named until 1950. During that time frame, the first Category 5 made landfall in the United States. This storm was known as the Labor Day Storm of 1935. It made landfall in the Florida Keys with sustained winds of 185 miles per hour. This is only one of 4 hurricanes that made landfall in the U.S. as a Category 5. Hurricane Camille in 1969 is the second strongest landfalling hurricane in the U.S. history, hitting southern Mississippi with 175 mile per hour sustained winds. 1992's Hurricane Andrew is infamous to Florida, the most catastrophic to hit the state, and scarred Dade County with 165 mile per hour winds. And the most recent was Hurricane Michael. That devastated the Florida Panhandle, wiping out part of Mexico Beach with 160 mile per hour winds in 2018. 2024's Hurricane Beryl and Hurricane Milton became the 41st and 42nd Category 5 hurricanes on record in the Atlantic. Now some Cat 5 stats. The strongest was Hurricane Allen, which had a peak sustained wind of 190 miles per hour. There's a 4-way tie for the second strongest hurricanes, peaking at 185 miles per hour. Wilma's also on here, but owns her own record for the lowest barometric pressure recorded in the Atlantic. And lastly, Beryl recorded its own record in 2024. Beryl's now the earliest Cat 5 on record, hitting 160 mile per hour sustained winds on July 2nd, 2024. Category 5s are becoming more and more common. 18 have formed since 2003, and 10 have formed over the last 10 years.
So we've learned how storms form, but what factors can hurt a storm's development? Brittany Van Voorhees shows us what weakens a hurricane.
Tropical cyclones thrive in warm ocean waters due to the heat and moisture the sea provides. As the storm encounters more warmth and more fuel, it'll grow stronger and become more intense. So what can stop a tropical storm or hurricane? Let's raise your weather IQ. Number 1, wind shear. Wind shear hurts a cyclone by shearing or ripping apart the top of the storm. This disrupts vertical motion and doesn't allow updrafts to form a typical tall thunderstorm cloud. This prevents a tropical system from forming a close center of circulation, which causes them to sometimes appear lopsided. This can also lead to tropical storms and hurricanes being unable to strengthen. Number 2, land interaction. This can do a number on a tropical cyclone. Land weakens the storm due to the lack of moisture and heat sources. This impacts the cyclone's ability to produce storms near the center, which will eventually cause the eye to collapse and the storm to weaken or dissipate. Sometimes you might hear a meteorologist talk about the Caribbean mountains having a similar effect. This occurs much quicker due to the taller nature of the terrain, which disrupts the winds circulating around the low pressure. Number 3, dry air. Since hurricanes are like a steam engine sucking up all of the available moisture, any dry air or Saharan dust will immediately halt production. Even if warm and moist ocean water is present, dry air can erode a tropical cyclone from the inside out. Another less common impact is upwelling from a previous storm. Upwelling pulls deeper, colder water from the bottom to the top of the ocean surface. So if another storm tries to play follow the leader, it would hit the area of colder water and just fall apart. Why? Tropical cyclones need water temperatures of at least 79 degrees Fahrenheit in order to develop or strengthen.
Hurricane Helene, it was one of the most devastating hurricanes to hit our area in decades. Coming up in the next half hour, we take a look at how communities are rebuilding. And later, did you know that both NOAA and the Air Force have hurricane hunters? We walk through the different tasks each agency has when it comes to their air crews. Now on WCNC Charlotte, Hurricane IQ, a WCNC Weather Impact Special continues. It's been more than 8 months since Hurricane Helene devastated western North Carolina. We're going to head back to Chimney Rock to see how the rebuilding is going there. Plus, this hurricane season, we will face a new challenge, budget cuts to the National Oceanographic and Atmospheric Administration, how this could impact you at home. Thanks for sticking with us here on WCNC Charlotte. I'm Chief Meteorologist Brad Panovich. Hurricane Helene was the worst hurricane to hit our area in decades. Helene made landfall in Florida in the Big Bend region as a Category 4 hurricane, but then the storm moved up the East Coast, decimating western North Carolina. The storm brought catastrophic inland flooding, extreme winds, landslides, and numerous tornadoes. The strongest wind gust in North Carolina was close to 106 miles per hour up on Mount Mitchell. Some parts of the state saw 30 inches of rain, possibly as high as 40 inches from Helene. Helene is responsible for at least 250 fatalities in the United States alone, including 176 direct deaths, many right here in North Carolina. It was the deadliest hurricane in the U.S. since Hurricane Katrina back in 2005. Now, Chimney Rock, it was one of the hardest hit areas. Now, after months of hard work, Chimney Rock is slowly coming back to life. WCNC Charlotte's Jesse Pierre traveled to the area and shows us more about the efforts to rebuild one beam at a time.
Chimney Rock Village took a major hit, and although full recovery will take years, the goal is to reopen partially this summer. I spoke with people helping rebuild from the ground up, holding on to the spirit of what was while shaping what's next.
A mountain community filled with stories and cherished memories.
It's got a magical draw to it that once you get here, you just want to come back or you want to stay.
That's Chimney Rock's mayor, Peter O'Leary. He started his business here 30 years ago, one of many buildings devastated by Helene.
This building was destroyed by the flood, and everything washed away, washed downstream.
There was no access here close to 7 months ago.
Shane Zaccoli is the founder of Spokes of Hope, a nonprofit that helps disaster-stricken communities. He showed us some of the progress being made.
Everyone that's touched this valley to bring it to this place, it'll bring you to your knees in tears because it's impossible to do it by yourself.
Despite the devastation, some lakeside buildings survived while others are being rebuilt.
So this is the beginning of replenishing an 1817 bed and breakfast.
A lot of the debris has been cleared, but the cleanup continues. Temporary bridges are in place, and a permanent bridge is under construction to connect to the state park. Workers are also replacing the water and sewer system. Over on Main Street, some of the businesses once buried in mud now have new walls and floors, and nothing is going to waste.
That hand railing you see has come out of another house that we demoed.
Even this counter space was crafted from salvaged wood, now designed with the Broad River flowing.
Every stone is the people that worked in this building.
While the landscape has changed, the spirit of Chimney Rock remains unbroken.
The old Chimney Rock is gone, but the new Chimney Rock that we're going to rebuild, it's going to be an amazing place.
One stone at a time. Progress is giving the community hope as they look forward to welcoming people back in town. The recovery here is about more than just rebuilding structures. It's about preserving the heart and soul of the mountain. Jesse Pierre, WCNC Charlotte.
Can't wait to get back to Chimney Rock someday. Now, the flooding is the second deadliest type of weather event we can have. And with Helene, we saw widespread flooding throughout western North Carolina. Becca Birdsall has more on the dangers of flash flooding.
Flash flooding is one of the most dangerous weather threats because it can happen quickly, turning roads into rivers and putting lives at risk in just minutes. Flash flooding happens when intense rainfall overwhelms drainage systems or natural waterways. Low-lying areas, especially near rivers and creeks, are at the highest risk, but even urban areas where pavement prevents water from being absorbed can see dangerous flash floods. During Helene, the North Carolina State Emergency Response Team rescued more than 1,500 people and over 250 pets trapped by floodwaters. Here's how you can stay safe during flash flooding. Stay weather alert, have a way to receive alerts from the National Weather Service. Know your risk. If you live in a flood-prone area, be prepared to evacuate. Never drive through flooded roads. Move to higher ground immediately if a flash flood warning is issued. The most important thing to remember, turn around, don't drown. It only takes 12 inches of fast-moving water to carry away a small car and only 6 inches to knock you off your feet. Plus, you don't know what lies in the water. There are often hidden hazards that floodwaters conceal, like debris, washed out roads, or electrical risks. When you see traffic barriers that close off flooded roadways, don't ignore them. Hurricane Helene showed us just how devastating flash flooding can be in the Carolinas. Severe weather preparedness week is the perfect time to make a plan for you, your family, and your pets in case disaster strikes. With the WCNC Weather Impact Team, I'm meteorologist Becca Birdsall.
Now, following Helene, there was a lot of misinformation floating around about why the storm was so strong. Brittany Van Voorhees breaks down its impacts.
Helene was a devastating storm for western North Carolina. And while meteorologists and climate scientists know the storm was enhanced by climate change, some of the impacts were just due to an unfortunate weather setup. Let's raise your weather IQ. First, let's look at what we know about tropical systems and the Atlantic Basin. 1, the oceans are getting warmer, and so is the air. 2, warmer air holds more moisture, leading to heavier rain. And 3, above average ocean temperatures allow for rapid intensification. Helene rapidly intensified partially due to water temperatures in the upper 80s, which are well above normal. The higher that number goes, above 80 degrees, the more fuel for a hurricane. When water warms, it expands and takes up more space. When the air warms, it holds more moisture. This allowed for Helene to dump a significant amount of rain as the storm pushed inland. So, did climate change enhance Helene? Yes, but it was not the only factor. A predecessor rain event in the form of a stalled front produced multiple days of rain and even severe weather before Helene. On top of the PRE, Helene was so large that moisture streamed in ahead of the storm, essentially mixing with the front and enhancing the storm potential. Climate change does not produce a PRE. In this case, it was just horrible timing. Geography of the Carolinas also played a substantial role in Helene's impact. Due to the position of the storm, upslope flow, or wind up the mountains, shoved a bunch of tropical moisture into those mountain areas. Combined with the terrain, this heightened the threat of flash flooding and landslides. All the heavy rainfall also led to swollen rivers, lakes, and streams, which only exacerbated the flooding. For WCNC Charlotte, I'm meteorologist Brittany Van Voorhees.
During the hurricane season, communities rely on accurate forecasts to stay safe. But this year, meteorologists are facing an unexpected challenge: budget cuts to NOAA and the National Weather Service. NOAA and the National Weather Service are responsible for tracking hurricanes, issuing warnings, and collecting weather data. They've had a huge reduction in funding. The funding for this year was already cut 10%. For next year, the proposal is a 27% cut from the 2024 levels. Now, many local forecast offices are already working with reduced staffing levels, so they're relying on remote help from other offices. A lot of these offices are already in hurricane-prone areas. We've also seen a huge reduction in weather balloon launches due to staffing issues or lack of funding. Now, key programs, including storm research, forecast models, as well as aircraft reconnaissance missions like the Hurricane Hunters, have all been scaled back. Many have warned that this could make hurricane predictions less precise, leading to delayed evacuations and increasing risk to coastal residents. For instance, in previous seasons, we've had unlimited resources to send multiple aircraft into storms to collect data in real time. Now, with fewer flights and reduced staffing, the ability to predict a storm's path and intensity could be compromised. In local communities like Charleston, Wilmington, and New Orleans, emergency managers are concerned. Without precise storm tracking, officials fear evacuation orders may be harder to issue. Timely, accurate forecasts save lives. If we don't have reliable data from NOAA, it could put families at greater risk during the hurricane season. Now, experts are warning that the consequences of these budget cuts could be, tremendous. So advocates are pushing that they get restored almost immediately. Now, in the meantime, meteorologists and emergency officials urge residents, you got to stay informed, be prepared early. Even with reduced staffing, the dedicated men and women in NOAA will work with the resources they have to make it really safe out there. It just makes it harder and more stressful in times of very active weather. When we discuss the impacts of inflation here on WCNC Charlotte, we typically talk about the grocery store. But did you know inflation can also affect hurricane season? Chris Mulcahy shows us some of the costliest storms in history and what the price tag would look like if they happened today.
The United States has had at least $1 billion tropical disaster for 9 years in a row now, and the cost of tropical storms and hurricanes goes up every year. Here are some of the costliest hurricanes and how those costs have increased over the years. Over the past 30 years, our average damage cost has increased around 3 to 4% every year. So when you look at historic storms in 2024's dollars, the amount is staggering. Katrina is one of the most infamous hurricanes, but it's also the costliest. In 2005, Katrina made landfall as a Category 3 hurricane, but caused $125 billion in damage. Well, based on the 2024 Consumer Price Index, that cost would now be $200 billion. That dollar amount has risen 60% in 19 years. The second costliest was Hurricane Harvey in 2017. Harvey was a major hurricane at landfall and made history when it stalled over eastern Texas and rained for days. Harvey caused $125 billion in estimated damage, but that cost in 2024 dollars would be over $33 billion more compared to just 8 years ago. 2022's Hurricane Ian was a devastating storm that caused $111 billion in damage. Well, that only happened 3 years ago, and now the costs have already gone up $6.7 billion. And Hugo caused $9 billion of damage back in 1989. The cost in 2024, $22.6 billion, a whopping 151% rise in inflation. Taking a look at 2024, Helene cost $78.8 billion in damage and was the 7th costliest on record. Just a month later, Hurricane Milton became the 11th costliest storm, causing $34.3 billion in damage. Let's stop here. Notice how I keep on referencing 2024 instead of 2025? Well, it's due to cuts and policy changes. NOAA's National Centers for Environmental Information, the NCEI, will no longer update the billion-dollar weather or climate disasters product. 2025 will technically have $0 billion disasters because they won't be documented. For now, Helene and Milton will be the last billion-dollar damage-causing hurricanes documented. But even though the numbers going forward won't be calculated, we know they won't be the last.
Coming up, both the Air Force and NOAA have hurricane hunters. We walk you through the difference and what each does coming up after the break. And then later, we're going to take you inside a wind tunnel. You got to see this. A Category 4 hurricane. What does it look like? Chris Mulcahy is going to show you. As you know, hurricanes are one of the most destructive forces in nature. But thanks to dedicated teams flying straight into the eye of the storm, we get life-saving data. Tonight, we look at two groups taking on that challenge: the NOAA hurricane hunters and the Air Force hurricane hunters. They fly into chaos, braving turbulence and pounding winds, all for safety and science. The NOAA hurricane hunters and the Air Force's 53rd Weather Reconnaissance Squadron share the exact same goal: tracking storms before they make landfall, but their missions are slightly different. NOAA's hurricane hunters focus on research. NOAA has two Lockheed WP-3D Orion 4-engine turboprop aircraft. Now, they're affectionately nicknamed Kermit and Miss Piggy. They probe every wind, pressure change, repeating this very often for a grueling schedule again and again during the course of an 8 to 10 hour mission. Their WP-3D Orion aircraft carries cutting-edge instruments gathering scientific data to help improve storm predictions. NOAA's Gulfstream aircraft, which can fly high, fast, and far with a range of 4,000 nautical miles and at a cruising altitude of around 45,000 feet, it paints a detailed picture of the weather systems in the upper atmosphere around developing hurricanes. This helps in forecasting the steering currents so we can figure out where these storms are going to go. Meanwhile, the Air Force hurricane hunters, they fly WC-130J aircraft straight into the storm, collecting real-time data for immediate forecasting, positioning, and disaster response. The data these teams provides helps emergency responders make critical decisions. Without them, forecasting would be far less accurate. But challenges remain. NOAA's fleet faces budget concerns while the Air Force squadron juggles military readiness, storm tracking, and despite those obstacles, both teams continue their high-stake mission, ensuring that the public is informed and prepared. Taking a look at the stats from last year, the NOAA hurricane hunters flew 392 mission hours to collect atmospheric data. The hurricane hunters passed through the eye of a hurricane 80 times. The Air Force's Hurricane Hunter Squadron, they flew 107 missions and 1,130 hours into 14 storms. Last hurricane season, Helene and Milton dumped unprecedented amounts of rain, which some experts called a once-in-a-1,000-year rain event. But some claim this should be considered a 1,000-year flooding event. What's the difference? And what does it all even mean? Brittany Van Voorhees walks us through it.
When you roll a die, the chance of getting the number you want will always be 1 in 6, no matter how many times you roll. This is a recurrence statistic, meaning the likelihood an event will occur. 1,000-year rainfall events are the same. It's the likelihood or probability an event of this magnitude will happen. If you love numbers, think about it like this. A 1,000-year event has a 0.1% chance of happening in any given year. While chances are low, you can have 2 events like this in back-to-back years. While a 1,000-year rainfall event is a singular event, this does not always result in a 1,000-year flood. Flood recurrence measurements are based on the level of water within a specific creek, stream, or river. The same event, for example Hurricane Helene, may result in a 1,000-year rainfall, but not a 1,000-year flood. These factors may include rainfall totals across the entire basin, dry versus saturated soil, and size of basin compared to rainfall duration and intensity. USGS collects this information over time and calculates statistical data for each specific basin. The more years of data available, the more accurate the estimates. Some basins may not even have data for 1,000-year floods due to their rarity. For WCNC Charlotte, I'm meteorologist Brittany Van Voorhees.
Coming up, we're showing you the power of a hurricane as meteorologist Chris Mulcahy visits a wind tunnel to experience Category 4 wind speeds. And you've probably heard the phrase, the dirty side of a hurricane. But what does that really mean? We'll explain coming up. Not all sides of the storm are created equal. Majestic Storm walks us through the dirty side of a storm and why it's so dangerous.
With tropical systems, your location does matter when it comes to what kind of effects you'll see from the storm and what kind of damage you can expect. You may hear us say something about the dirty side of the storm. So what is that and why is it different? The dirty side of a storm refers to the area of a hurricane or tropical system where you'll find the highest winds, highest storm surge, and the greatest tornado threat. So what kind of storm is that? Well, generally it's the northeast side of the storm, or more simply put, the right side of the storm. But it also depends on which direction the storm is moving. If it travels in a northern direction, the dirty side will be more on the direct right hand or eastern side. If the storm is traveling in a more western direction, the dirty side will be more on top of the northern side. So what makes it so dirty? It's all about the wind direction and a little math. For example, if a storm is moving north at 30 miles an hour and has a wind speed of 100 miles an hour, then the storm will produce winds of 130 miles per hour on the right dirty side, while on the left side, winds move in the opposite direction of the storm's movement, so they'll be slower at 70 miles per hour. It's important to remember, though, as a storm grows stronger, every side becomes dangerous.
Coming up, we're showing you the power of a hurricane as meteorologist Chris Mulcahy visits the wind tunnel to experience what a Cat 4 storm feels like. Tonight, we've covered a lot of the science behind hurricanes, but we're also getting a first-hand look into the power of a hurricane. Chris Mulcahy is turning the winds up to a Category 4 storm to show you just how powerful they can get.
We're here at the Aerodyne Wind Tunnel, and what are we going to do? We're going to demonstrate the power of a hurricane's winds. We're going to go from tropical storm 1, 2, 3, and then max it out at a low end 4 at 130 miles per hour. All right, it's getting real. All right, let's experience a hurricane. This is the Aerodyne Wind Tunnel, 250 feet long, 2,500 horsepower. The main thing about this simulator, you don't have the rain, you don't have the debris. This is just showing the pure power of the winds. Okay, let's do this. This would be tropical storm strength. You can walk. Picture this as a strong thunderstorm pushing through the area. But once you get to 74 miles per hour, that's Category 1. Let's go Category 1. You can feel the difference. A Category 1 is gonna rip off shingles, roof tiles. Let's go Category 2. A Category 2 hurricane is winds at 96 to 110 miles per hour. I can't walk forward on my own. Debris can be thrown into windows. I can barely speak. It's an extremely dangerous situation to be outside. Let's go Major. Ramp it up to Category 3. You can feel the difference! You can feel the difference! Roofs can be blown off! Both Category 4 and 5 hurricanes produce catastrophic damage and can leave areas uninhabitable for weeks, even months. The power of wind increases exponentially. Just look what it does to my face as we increase to major hurricane status. Cute, right? Something I truly never want to experience in real life, but thanks to Aerodyne for showing us the force of a hurricane. I'm meteorologist Chris Mulcahy, WCNC Charlotte.
I think Chris's cheeks are still feeling that. Thank you for joining us tonight on WCNC Charlotte for Hurricane IQ, a WCNC Weather Impact Special. A reminder, now is the time to prepare. Just because we're not on the coast doesn't mean we're not impacted. Make sure you always have a way to receive weather alerts. Make it 3 ways and make a plan just in case of power outages or flooding. Good time to put that kit together. That does it for here on the air. But join us now on WCNC Plus for an extended conversation. Just download it for your TV and watch it for free right now.